I think I give some formulas for you. Like I give another alternative method. No, what is the alternative method? We know the charge will increase exponentially. So find steady state charge and calculate the time constant, and directly you can write expression for charge. Or else, what you can do, you can come for loop equation. In the loop equation, you should be very particular about the distribution of current. So let the current flowing through capacitor be I1. Let the current be I1. Let the current here be I2. Let this be I3. This will be a fixed current. I'll write capital I3. Where current variable, I'll put small letters. So let the charge be Q minus Q. Polarity plus minus plus minus. Let's write loop equation plus V minus Q by C. What is the current that will flow here? It should be I1 plus I2, no? What all this current, it will branch like this. What all current I will branch I1, I2, I3. That here, the I1 plus I2 will combine, will become I1 plus I2. So V, I'm writing loop equation plus V minus Q by C. Here, I1 plus I2 into R1 equal to 0. So to solve this, what is the thing? Which current is responsible for the increment in charge across capacitor? It should be I1. With this one, it should be I1. So therefore, shall I write I1 equal to dq by dt? Not I2 equal to dq by dt. The current in the capacitor branch is responsible for increment in charge. So then there's no problem. I1 I can write dq by dt. What to do with I2 is what we have to search. So I'll write one more loop equation plus V I2 R2 I1 I2 R1 equal to 0. So V is equal to V minus I1 R1. Substituting this, value of I2 you have to substitute in equation 1. Put 2 in 1, so then you'll get all the whole equations in terms of I1 and dq. Then integrating will get expression for charge. So this will be this. In fact, R1 equal to R2, R1 equal to R2 equal to R3 equal to R, no. So therefore V minus I1R by 2R. It is substituting this I1R minus I2R equal to 0. So V minus Q by C. What is value of I2R? Will be V minus I1R ordered by 2. If you're not confident of this writing loop equations, so what is the alternative method? Find the steady state charge, find the time constant, and manage the problem. So this will be V by 2 minus Q by C. Q by C. This will be minus I1R by 2 equal to 0. I1 equal to dq by dt. Now substitute this. Afterwards, I think it is similar to, you can manage this equation very comfortably. So any number of loops come, more than one loop comes, okay. The method is just only introducing the loop method. Or here branch current I applied. Or sir, instead of this, can I assume loop currents? Yes, you can assume it. Then write it, you'll get same answer. All these are different methods, that's all. So the final simplification, this will be equal to VC minus So this will integrate.
Sir, RC by 2.
RC will come. Okay, dq equal to vc by 2 minus q equal to dt by rc by 2. T equal to 0. There is no initial charge. Integrating will get the required answer for charge at any time t.
Sir, VC by 2.
I'll make changes. So they should be equal to q equal to vc by 2 1 minus e to power of minus 2t by rc. This is the expression for charge in capacity anytime. Any other method, find out the time constant, find out the steady state charge. The steady state charge should be here. This is the steady state charge, and this is the time constant. RC by 2 is time constant, but sir, 3 resistors are there. So you can't say no. Now you can't just say that, sir, this should be the R and C are parallel. So time constant will be determined by only this, nothing to do. The time constant of circuit, here you have to look at the equation in the end equation, or else what is the alternative method? Replace this cell with short circuit, make it EMF 0, then this resistor R1 will be shorted, then effective resistance as seen by this R1 R2 parallel, so R1 equal to R2, so R by 2. They may ask you only time constant. So there are two approaches are there. What is another approach? Other approach is where all cell is there, you have to make EMF 0, then replace the cell with a, if any internal resistance are there, replace with internal resistance. Since there is no internal resistance, so I'm replacing with a short circuit. So this will be like this. You should be very alert in the problem. They may ask you only time constant, so you can't write this much of mathematics. Huh? You have to be very careful. You can't just, for that small problem, no, you can't just go like this here. So better use this one. So what is CAB? R1, R2. What is RAB?